This section is called Open Sentences and Two Variables. Your book is a bit of an older book, if you've noticed. It's a great book because it has really good questions, but it's a bit older. So the topic names are a little different. What this is really equations with two variables. So functions, y equals mx plus b, right? Remember you've looked at linear functions? That's what the beginning of this chapter is all about. We're going to see systems of equations here. We're going to do a lot of cool stuff with this chapter. I like this because we finally get into some cool math that we can apply. So we're going to find solutions and we're going to look at them as ordered pairs. Why are they ordered pairs? Ordered pairs give values for what variables? X and y. Some independent and some dependent variable. Very good, x and y. Okay, we call them in math independent for x and dependent for y. Because the y value depends on the x value. That's the reasoning for the names. We'll get into more of that in a little bit. So this is what we're talking about here is a pair of numbers that satisfy the answer. There's no longer a simple single solution. So let's look at the first one. Find 5 different solutions to the following. This is a very easy question. Find 5 solutions. Pick values for x. Doesn't matter. Pick values. Give me 5 values for x. Let's see. Max. 5 values for x. I don't care what they are.
1, 2, 3, 4, 5.
Max went the good route. I like it, Max. All right. Good idea. That's a smart way to go there. Okay, makes trends easier to pick up on. Yeah, you can pick random numbers, but he was like, I might as well pick consecutive numbers so I can pick up on a trend. Now, I want to figure out the y values that coordinate with these x values. Obviously, I don't want to do this 5 times, right? I don't want to plug in 1, solve for y, plug in 2, solve for y. I would never waste my time and plug these in 5 times because you guys are all advanced math students. So instead of plugging in 5 times for x, what should I do first? What should I do first? That might help me to figure out the y values a little bit quicker. Again, if I plug in a 1 in this equation, I have to solve for y. Plug in a 2, solve for y. That's so much work every time. There's a way to make life easier. George?
You can find the trend by doing like x is equal to y is 1, 2, 3, 4.
You might be able to find a trend. That's one way to do it, but there's an even easier way. But that is one way. You could maybe find the first 2 data points and find the trend and follow it. Okay? But I would find an even easier way than that. Think about it. We did it earlier this year. We did it already once. We did it with volume at one point, if you remember the problem. It had to do with volume. The volume of an object.
Solve for one of the variables.
Yeah, solve for one of the variables. Well, which variable do we not know right now?
Y.
So which one should we solve for? So go ahead, solve for y. Do not plug in x. Do not plug in a number for x. Solve for y. I'll give you a hint. If you're confused, move this whole thing over first. If you get confused on the first step, move the entire expression 4x over. And then solve for y, yep. But remember, without plugging in numbers for x.
Is it 8 minus 4x over 3?
So let's go through it. Do you mind stepping me through a bridge? Because you're right. So give me the next step. What should the next line look like? When I move the 4x over, what does it look like?
Oh, so when you move the 4x over, it's 3y equals 24 minus 4x.
Okay, and then?
And then divide by 3 on both sides. So 24 divided by 3 is 8.
Good.
And then just 4x over 3.
Yes. And I'm going to write it like this, Bridge, okay? Same thing. The reason I write it like this is because now I know, because I teach math a lot, here's my slope, here's my y-intercept. Okay, we can already see that if you know your linear functions. We're going to go over the basics of linear functions still. So if you're confused about slope, I'll go over it. But it is something you should have some knowledge about. Slope simply means, all this means, is the change. This means that you're going to go down 4 over 3, down 4 over 3. So the graph is going to look like that. It's going to have a negative slope because of the negative. This is a positive slope. So if you're a little confused still, we'll do all the basics of this. Now that we've solved for y, it is very easy to finish this problem. Go ahead and plug in the 5 values for x, please. Now, the annoying part is going to be fractions here, isn't it? So that's fine, though. I'm actually happy because I want you guys to struggle a little bit with these fractions. If you want to, it might be easier to not write this as an 8 and to use this as your expression right here. Look what I circled at the top in blue. y equals 24 minus 4x over 3, it might be easier to plug in numbers for x here because you already have a common denominator instead of making a common denominator 5 times. You follow what I'm saying? Yes, no, maybe so? Again, I'd probably use this, what I circled here, as an expression for y when plugging in for x, because now you're going to have to make a common denominator 5 times. So I would probably use this value right here. Or if you know slope well enough, you could pick up on the trend. So if I plug in a 1 up here for x, I get 24 minus 4, which is 20, and I get 20 over 3 is 20/3. If I plug in a 2 for x, I'm going to get 24 minus 8, which is 16, and then 16 over 3 is 16/3. We don't need to write these as mixed numbers. Improper fractions are absolutely okay. Mixed numbers are something that are useful when you're talking about number sense, if you need to know how many whole parts there are. But when it comes to representing a number, improper is actually an easier way to represent than mixed numbers. Okay, you'll see this a lot going forward. Although in middle school you learn always mixed numbers. You can leave improper, that's fine. It's not really improper. The term improper simply means that the numerator is greater than the denominator. Picking up on the trend, if I plug in the next number, what is it going to be? 20 over 3, 16 over 3, go. 4?
3.
Oh, yeah, but give me in thirds. 12 over 3, which, yeah. Thank you. Duh. Keep going. Trend. I want the trend again.
And then it's 8 over 3.
And then it's? Yeah, what's happening? What's the trend? Pick up on the trend, Annette.
Tracking by 4.
Yeah, each numerator went down by 4 every time. The numerator went down by 4. Why is that? Because the slope was negative 4/3. So the third portion was still thirds every time. The negative 4 going down the numerator had to do with the slope. We'll get to that again later. But do you see how there were 5 coordinates now? How would you write those 5 coordinates? You'd write them like this.
So 6 or, yeah.
Good? Am I answering it by writing it?
So for 6, 0.
6 would be 0, actually. Yeah, and try it. Would it work? Check it out. Plug it in. Tristan, you agree? If you plug it into the original on top right, go up here, look. Plug in a 6. 24 minus 24 is 0. Okay? So if you plug in a 6 for the next one, take another 4 away, you get 0 over 3, which is 0. So those are your 5 possible answers. How many possible answers are there? How many? Infinite. And I try to hold the call on you. That's okay. No, you're absolutely right. Infinite. There are an infinite amount of answers. Because a line is really an infinite amount of points touching each other. Think about what a line is. If I want to draw a line with a marker, of course there's no marker in this room, God forbid. I'm going to draw a line with a marker for you. And I'm going to use the smallest size so I can use dots. If I were to draw a line, I could do this. Let me use this one. Right? Look at all these dots, one after each other. And if I want to draw a straight line, obviously, those dots would line up and they'd all be collinear, all those values. But a line is an infinite amount of dots or points. So the answer to this is yes, there's an infinite amount of them. The second one asks you, given these are the x values, solve the equation, meaning come up with the other coordinates. So these are all the x values. I'm going to skip this one. I'm going to tell you what you're going to be doing though. Look, this, it says if the domain of x, domain, write this down if you need to, means the values x can take on. Domain, the word domain means the values that x can take on, the values that x can be. What can x be? X can be negative 2, 1, 5, and 7. So you're going to have 4 answers to this. Negative 2, comma something. Negative 1, comma something. 5, comma something. 7, comma something. You follow what I'm saying by something? Okay? I'm going to allow you to do this one on your own just because I want to get through this and there's more interesting questions in this. This is kind of the same thing as the last one, but instead of max, remember you picked 1, 2, 3, 4, 5? Now I'm telling you these are the x values by saying the domain is this. And now I want you to find the y values just like the last problem. It's the same thing, except the domain is now specified. I'm giving you a specific domain. The third problem, this is the one I want to work on now. Okay, Paul has $22. He buys notebooks costing $2 each, Binders costing $5 each. If he spends all $22, how many of each does he buy? There are only a certain amount of answers to this because of the nature of the problem. Why? What restricts our domain here? What restricts the x values that it can take on? Why is there a restriction to the values that x can be? What must x be?
It must be equivalent to each side because you spend all 22.
You spend all 22, so x has to be what kind of a number though?
A whole number.
A whole number. X might be the number of notebooks. You can't have 0.5 notebooks, right? So your domain for this problem, your whole numbers only for sure. What else? What other kind of numbers can't you have? Negative. You can't have negative amounts of supplies. Okay? So let's start by writing this. First, if notebooks cost $2 each, let's let x equal, let x equal the number of notebooks. And we'll let y equal the number of binders. So, how much is it for a notebook? How much? $2. Bridge, if I have 3 notebooks and they're $2 each, how much do I pay? $6. What did you do? You multiplied them. He took the cost per each notebook and multiplied it by however many notebooks he has. 2 times 3. That's how you know to write this to start. Then, how about binders? How much do they cost each? Thank you. And you spend how much? There's your starting point. Again, use logic and common sense. I got to stop at this point. Okay, 2x, 5y, 22. Let x equal 0, 1, 2, 3, 4, 5. Figure out your y values. Only whole number answers are appropriate though. So as soon as y becomes negative, you have to stop. So in this case, again, start with 0 for x. Let's see. I think we can go all the way up to 11, but there's a couple that we have to skip. All the way to 11. 11 will work, but there's a couple along the way that will not work. For example, if you try the number 2, and you try 2 notebooks, 2 notebooks will be $4. That'll be $18 left. And if binders are $5 each, is that going to work? If you have $18 left and binders are 5 each, it doesn't work. You've got a decimal. So you could already rule this out. Whoops. You could already rule this one out. It's not going to work because this would be a decimal value. So any decimal values you rule out right away. Any negative values you rule out right away. Okay? Why did I stop at 11? What's 11 times 2? 22. So if I buy 11 notebooks, here, it's going to use all $22. That's the most I can go to. So try your numbers from 0 to 11. See which of them give you whole number solutions. I know I have to stop. Is that what you're both telling me?
Yeah, also I was like, can you just tell that 5 only has 2 possible.
So, because 5 it could be 5 times 1, 5 times 2, 5 times 3, 5 times 4. Absolutely. So you can set y equal 1, 2, 3, 4, and then solve for x. Absolutely, George. Listen, what I wanted to say was this. Over the next 5 days, I expect you to come in with an outline of your project, please. Your homework over the next 5 days, I'm on Kairos, you don't have a lot of work, 3-1 is easy. You're going to watch the last example, do this homework, that's fine, but I'm going to put on Moodle that I want you to have the beginning of your project ready. What are your criteria? What are your different options you're going to decide? Remember all those tables? I'm not saying the project should be done, but all of your raw data should be collected. All of your raw data by Monday, try to collect. So if you're doing different burgers or something, collect all the data on burgers, calories, costs, whatever, blah, blah, okay? Collect your data, please. Bring it all in for Monday. We'll work on that on Monday in class. Have a good break. Go for it.
Okay, so
You're both, yeah, it doesn't matter. It doesn't
that
matter.
there was, it said to submit your project.
Yeah, whatever project.
How do I submit that to you? 'Cause I
Email
had
it,
that-
send it to
I had
me.
for like weeks.
Email or send it, doesn't matter.
Okay, I'll just email it.
Yeah, it doesn't matter. You're good. Yes. No problem. You did very well on this.
Yeah, I worked hard on it.
Oh, I
Like
can
the one
tell.
before I did in one night, and I did it.
And it was tough. You noticed that, right? One night it's really tough to do it. Perfect score. 20 to 20. You're the top scoring class.